Welcome everyone to our DASH session, Vibe Coding for Healthcare 101. My name is Steph Chia. I'm the Senior Research Manager at the UBC Department of Medicine, and I also help manage the UBC Data Science and Health, or DASH, research cluster activities. Before we begin our webinar today, I would like to acknowledge that we are hosting today's meeting from the University of British Columbia in Vancouver, which is on the traditional and unceded territories of the Coast Salish peoples, the Musqueam, Squamish, and Tsleil-Waututh First Nations. I also want to acknowledge that you may be joining from various locations and territories, and I want to acknowledge the traditional caretakers of those lands. So welcome everyone. Thank you for joining. Today, Dash is pleased to welcome you to our second session of Vibe Coding for Healthcare 101, which is building research tools with Vibe Coding. So today's session follows the session we had 2 weeks ago with Dr. Omar Saleem. What is Vibe Coding and why does it matter for health? So the first session we heard about introduction to the basics of how to navigate vibe coding, and we watched Omar build a live PubMed abstract screener as well. If you happen to miss the first session, that's okay. We did record it and it is shared on our Dash YouTube channel. So you can go back and watch that too if you have time. So without further ado, I would like to introduce again our speaker and presenter for this webinar session, Dr. Omar Saleem. Omar is a precision medicine physician and founder of Zinda.health, a precision medicine platform for South Asian health, as well as the co-founder of Dr. Vibe AI, an education and development platform that teaches physicians and healthcare professionals for vibe coding. And before I pass it to Omar, I do want to let you know that we're going to be using Slido today for any questions. So please either use the QR code or go to slido.com and enter the code here, where we will, you can type in all your questions and upvote any questions you see that you'd like answered, and we'll get to those at the end of the session. So I will stop sharing now and pass it off to Omar.
Cool. Me open up slides. Awesome. Hi guys. And great to have everybody back. It was really exciting the first time and had a lot of fun. That was one of my first times doing a live build, so it was a lot of fun doing it. So today it's gonna be very dense. I'm just gonna warn everybody. So if and I'm gonna give these slides, and also I'm gonna make some other tools that you guys can use afterwards to kind of practice and kind of play around with it. But basically, we're gonna be focusing on research. And research is one of those areas where LLMs and AI and vibe coding tools can be extremely powerful, to the extent that if you look at Claude's inception, so the reason Claude as a company, Anthropic as a company was founded, it was founded with the purpose of research. So that was their founding narrative. That their goal has always been to advance research, and that's what they still do, like Claude Scientific, which we're going to talk about. So that's why this is a very good area for both from a medical perspective, but also from an academic perspective. I think a lot of things to learn. So first thing I wanted to kind of give a lay of the land where we are. So we kind of have been building these layers. So then the first week we spoke about prompting, like how do you prompt an LLM? How do you bring the right goal from it? And then we kind of built a very basic workflow where we had a inclusion and exclusion criteria for papers, and it kind of separated the two between the different criterias. And so we built a workflow from there. Now we're going to be moving more into something more comprehensive, where real LLM use case kind of becomes powerful. So we're going to start with skill, and we're going to touch a little bit about automation. If we have time, maybe agents, but agents maybe next week or next time when we reconvene, then definitely we're talking more about agents. So skills. So what are skills? And what is automation? Because those two things kind of go together. So one thing that we know is that research. Why is research and why is QI? Why does it take so much time? Like why does it take so much effort from different people, different entities, getting data together? So it's a very messy process, and there's a lot of data that maybe doesn't need to be there. Some data that should be there that isn't in there. So and that is our role as researchers and as physicians, to kind of synthesize that and bring it together. That is one of our rules, and we'll talk a little bit more about that. And then kind of bringing the structured output. So that's a lot of what we spend our time doing. That maybe we should not be spending as much time. Maybe we can get that time back and kind of spend it more about thinking about how it is that we're applying all that information that we're getting, because that is true value where we can really make a difference. So LLMs kind of have this way of making things a lot easier, but it's also a very important skill. And it's something that you build as you work more and more with AI is understanding where it is that things or where it is an AI is useful and where it is that it's not. And I think that is extremely important to get the right answer. So when we break this down to two big categories, so anything that involves, and think of it like as a rule. So for me, the biggest rule is like anything that involves synthesizing, summarizing, bringing in patterns, showing you the patterns, not really deciphering those patterns, is a job of the LLM. When it comes to any kind of judgment and understanding if something is valid, if it's not, if it should be there or should not be there, those decisions, especially when it comes to very critical areas like ethics, like patient decision making, those should be human based, and that is where we should always draw the line in any tool that we make. So it is very easy to cross that line sometimes, and it's very tempting, but it is where we should always draw that line. And so when it comes to any kind of synthesis of data, any kind of converting different types of data sets into a readable manner, or coming building insights from different versions of like a study. So using different studies from different languages, bringing them all together in one place. That is all where an LLM can be extremely useful. Now, so again, going back into like what is that LLM an AI does? It always should be the draft. It should always be the one that's making the rough copy, giving an estimate of these are the things that are going on, but the decision again should be back to ours. And the way we make these decisions, so I have a six kind of set tool or 6 point tool that I kind of use for any tool that I make. Is so one is like, where is that tool coming from? Is it from credible sources? Is it pulling from Reddit versus is it pulling from PubMed, or is it pulling from some different sources like that? What are the criteria that we're using? That is extremely important, because a lot of times, and when we get to the automations, these agents can run at night, and it's like, is it sometimes missing a lot of information that should be in there, versus is it adding a lot of things that are not useful? And the next step is the output. What does the output look like? Is it something that I can read and understand, or is it something that I'm just going to skim through, so that then it's almost moot to have all that output coming out anyways? So it's also, and then the third thing is consistency. So to make sure that every output has a very standardized structure, so that if there's a third person who's reviewing this, it is very easy to understand and kind of follow along. And then the fourth part is the confidence, and this is very embedded in research already that we do, is understanding, is it statistically significant or not? Same thing with LLMs. How confident are they when they're making these summaries, and how confident are they when essentially they're coming to an answer? And we're actually seeing this play out significantly in the larger productization of AI, especially agents, where now we're building multi-agent structures where there's actually agents that are responsible for this. So their only sole purpose is what we call observability. So they are just observing the whole supply chain of agents and making sure there's confidence, and the system is in the right structure. So and then the next step, of course, is human review, which is critical and vital and can be skipped. And then the last is the audit trail. And this again goes back to observability. Audit, or what we call evaluations in agents, is extremely important, and it's becoming a bigger and bigger theme as these agents go into more mission critical tasks. So that's kind of just an idea of kind of how to build around an ecosystem around agents. Now, the three areas that I kind of wanted to focus on, and we'll probably only hit one. But the reason I mentioned all three is just to give a sense, or give kind of like a broad picture of like the different ways that this can be used. So the first is kind of building upon what we did last week, where we'll take and evidence structure. So in our case, last time what we had done was we took papers about GLP-1s and just to give an overview, and then we made an inclusion exclusion criteria based on what we were looking for, and the LLM kind of separated those two. Now we're going to take that to another level where it'll be live screening. So as those papers come in every day, every night it'll screen all the PubMed publications, find all those papers that have been published around the world, and then synthesize them, present them to us in a reviewable manner, and then and it'll be all done through public APIs. And then maybe when we have patients who may fit into certain trials. So if we can, we'll also connect to clinicaltrials.gov to get that kind of get those trials in there as well. So that's what we'll try today. The other one is QI, which I know is extremely important, especially in building better models. So that will be important in converting basically data points into something that can be used broadly system wide, and also creating models that taking systems current models and finding solutions that may be making more efficient. So I'm going to make that into a skill, and we'll talk a little bit about what a skill is. And same thing with the grant scaffold. So it's essentially like if there are grants that are being done, or if there's a research lab that is building a grant for anything, or an IRB even. So that how can we kind of automate that, and how can we do that for from a system side rather than a from the researcher side as well. So those are things we'll just touch upon briefly. So the the biggest thing with this is, and something to understand is, all of these tools that we're going to be using today are free. They're completely free, which is still baffling to me, because they provide all the research papers that you can get, all the clinical trials that are going on. These are just not even just say in the US or in one country, they're worldwide. And then the same thing with OpenFDA. So OpenFDA, of course, is US based, but that has all your drug interactions, adverse events that have been listed, and those are all updated very, very regularly. And then we can also use Statistics Canada. So that is also available through an API. So that's why I like to say you don't need a data set, you need an API you don't need. So you don't have to pay for any of these things. It's just a way to kind of connect it. So like I mentioned, V1 was what we did last time. It was basically a tool that got the information and then just classified it. V2 will be something a little bit more alive, quote unquote. So it'll be something that will update automatically, give us insights. When we open it at 7 a.m. in the morning on Monday morning, we'll have all those papers ready with insights and everything kind of broken down for us. So yep. So basically, this is what I want to kind of build out. So it's a so there's 6 steps that we want to do. So we'll pull abstracts. So we're going to pull that from PubMed, and I want to go over this now so that if I'm just going to paste it into Replit, it'll be a little bit. It takes about 20 minutes to make. So I don't think we have 20 minutes to make. So I already made one version of it, but I just want to break it down so that everybody has an idea kind of what we did. So it'll pull abstracts from PubMed. It'll also pull recent trial registrations from clinicaltrials.gov, and then it'll screen these against PICOS criteria. And the PICOS criteria can be adjusted. So PICOS, of course, is like the different criteria that we use, like in finding articles. And this can also be filtered out using an LLM, which we can try to do. If anyone's interested in trying it, we can try that live. And then it'll synthesize all of those, give insights that we can review, and then export it as an audit trail. So that'll be the plan. And then we'll kind of take it from there. So this is going to be our question: is do semaglutide and tirzepatide reduce MACE events in adults with obesity but with diabetes? So again, our PICOS is going to be, we're looking for adults with obesity who are non-diabetic, and our interventions are of course semaglutide, tirzepatide. And then comparators are standard and placebo. The goals, of course, the MACE, and then we're looking for RCTs primarily. So that's what we have. So again, going back to what we spoke about earlier, with this, so our criteria is clear. Our output format is we're gonna do that a little bit, and then our input, we have an idea as to where it's coming from, and then So that's yep. And then so the this is going to be our prompt. So the prompt is essentially build a single page insight surface for the PICOS question. So it'll have what the input should be, and this is your PICOS criteria, and then it will mention our APIs. We want to use PubMed API. We want to use clinicaltrials.gov. You don't always have to mention these. Sometimes if like Claude is very smart about picking these up, ChatGPT, like Codex, is sometimes good, sometimes not. So I've been hit or miss. So I always add the APIs in there. But usually most of them will like if you prompt it, like if there is an API for this, then get it and use it, and that's the best way to do it. And then this is our criteria, and then classification is like our inclusion exclusions, and this is how it's just synthesized. So cross includes surface shared findings, divergent findings, identify gaps, cite the studies behind every claim, and then in the inside surface, render every observation as a reviewable card, and then confidence band. So this is if you want to have like a confirm, reject, or like get a second opinion, and the third is the guardrails. So just make no claims without any in-text citation. So this keeps the LLM narrowed down into that area, and then mark uncertainty explicitly. So if it's not certain about something, so this is one thing to always understand with LLMs. They don't they're very overconfident beings, or object, whatever you want to call them. So if they are not given the instruction to recognize uncertainty, they will never recognize uncertainty. They'll be extremely overconfident saying that this is right or wrong. So just to always have this guardrail kind of prompt in there, just to make sure that it stays in line, and then the output. So this is how it should look like with the screen table and CSV. So most of this doesn't have to be there. What I like to do is if I have an idea, I'll take it and then maybe put it into Claude and be like, give me a prompt that has all these different components in there, or like break it down to things that I would need. And then you can use Claude, you can use Replit, again, Codex, whatever you would like to use to build it out. So again, going back to language, and this is our third principle from last time. If anyone remembers, it's clear communication. So communication has to be very strict, and so this is our inclusion criteria. This is our exclusion criteria, and so there's no areas where the LLM can get confused, because if this is running at automation right now, it's okay because we're doing one thing. But if you want to scale the system out, it has to have very strict deterministic guardrails. And so this is what we expect to kind of get back. So we'll get back in remember those three layers. So the prompt, the workflow, and the skill. So the skill is now what will get all this back. So we'll have one area that'll give us all this information, and then it'll give us the brief, and then all the insights on the bottom as to this is something that we want, and then a checkbox like this is something that we like. Do we not like this? We kind of move on. So yeah. So, and then this is the second principle we had spoken about, was iterative thought. So, the first version is never the final version. So we'll run into barriers and issues always, and there's always room for improvement with everything in life. So we'll iterate it and improve it as we go. And one thing with this is especially prompts to LLM. So as you get as agents are involved, it's always good to fine tune them and kind of tell them, okay, this is good, this is not good, this is something that I don't like this, and then it'll learn and it'll get much better as time goes on. And then so this part I wanted to spend a little bit of time on with and this is something that I think has been a focus this month, especially with a lot of hacks that have happened with vibe coded software. So reliability is something that it's one of those things that maintenance is not very fancy. It's not as shiny as maybe making apps, but it is extremely important. So whenever something is built, it should be built with a thought process that it can this run 1,000 times, 2,000 times, 10,000 times, so with reliability, the biggest thing, like we spoke about, is clear communication. So structured inputs, having clear criteria as to how things are run, having very fixed output format so that there's a lot of consistency, and then the source has to be very sound in terms of where it's coming from, and you can back trace all the way back to the exact source where that decision was made. So all those things are very important. And then what that does is it reduces hallucinations and it prevents omissions. That can be very dangerous. And then when it comes to code itself, which is a little bit out of this discussion, is that same thing with code. So like with code, you want to make sure you have all the security features in there. All the APIs are covered and nothing is leaking. So yeah, so now before we move on to section two, I want to go and do a demonstration of the Replit app, and then we'll do the skill because I think it goes better that way. So let me switch to Replit. Can you guys see this? Yes. Okay.
Yeah.
Good. Perfect. Yeah. So we'll start with our prompt. So I'm gonna paste the full prompt in here, and then that way we can break down the prompt and then iterate it on top of that, just for the sake of time. But what the way I had built it and was so so essentially this is our prompt again. These are inputs where we want all the questions. This is the default research question is in there so that it has an idea kind of what you are looking for. And I think this is a good place to kind of mention that is as many examples as you can give, the LLM is very helpful. So it gets a lot of context as to how you're thinking and what you're thinking about as the end goal for this product, and for the app. So if like our goal was more focused on clinical application versus if our goal was on basic sciences, it's like, okay, mechanisms of action, then having that in there would be very helpful because the results it'll give, it'll actually organize those based on that. And then so this is our default PubMed query is what we want. This is the workflow that we are want to kind of do. And this we mentioned this a little bit as far as the different things and different components and the guardrails. And and then the inclusion exclusion criteria. So we'll have it build that out. And while it's doing that, I actually was able to build this out. So I'll show you. So it took about 17 minutes for it to make. So that's why I didn't want to spend time on that. We'll focus more on what it shows, and then we'll talk about skills after that for the sake of time. So so this is what it built out. So on that same prompt, this is the result we got. So it was basically the header with research inside surface. This is the default question. We can always change that question to something else. And then this is our strategy. So, and then this has the populations, the intervention, the comparator, all these things are already built in. And this is filled in by an LLM based on this prompt up here. So if we change this prompt, the LLM will also change our exclusion criteria based on the prompt we have. So, and then we're going to run the analysis. And so now this is using Claude Sonnet. So what's happening now is we're sending out requests to PubMed, clinicaltrials.gov, getting all that information. Now Claude is going to go through all of that, all of the results from there. It'll create a summary of the articles. Then it'll create almost like a pseudo meta-analysis or a systematic review of those papers. Not really a real, of course, it can't replace because you're not mixing in all that data. You're not doing a lot of that analysis of that data. So it's not an actual meta-analysis, but it'll almost like a pseudo kind of understanding of that. And then it will present it in this form. So it has the different studies. It has a decision it made to include it or not. And all these studies are hyperlinked. So if you find, this is a study that, why was this study selected? You can actually go back to the whole study and it'll open up the whole study for you. And then what was the funding source? This is the number of people in trial. And then, then it will keep going down. So this is kind of how it's selected. And this is the maybe, this is an exclude. Now, this is the synthesis brief based on the 3 included studies, like across, and this is all from Claude that it wrote down. So based on across all included studies, both semaglutide, tirzepatide demonstrated. My screen is blocked. So the direction of reduction. So basically summarizing kind of what it showed, and this is what the study showed. This becomes very useful if you have especially quite divergent studies with different populations types or areas that are not as aligned. Then it's extremely useful from that perspective. And then it had the effect sizes for the different studies. These were some of the gaps. So this is the evidence that it did not include. And like the Surpass trial was ongoing at the time of the publication, so its results are not there. So there's something to keep an eye on. And what it can do is, if the results from the Surpass trial come in, it will actually every night and we're going to set up the automation right now, but every night when you run that agent, that will be taken care of. So that's our kind of synthesis. These are all the insights that came in from the results that we got. So, in large randomized trial of adults with obesity and pre-existing cardiovascular disease, but without diabetes, semaglutide reduced the composite cardiovascular death and MI risk. And so, if we agree with that, so then we're just going to confirm. So now it's been confirmed. So then it will understand that. And what that does, so this confirmation is basically a way to kind of confirm that this is something that is along its lines. So now it's improving the agent's ability to get that. Now, what if we wanted to kind of automate this? What if we want this to run every night? And so what I'm going to do is actually, can you add actually not every night, every week is better. No one releases papers daily that frequently. To manage. So what this will do is we'll create a dashboard that'll help us see all the automations that are running, and also and then it'll create a way to kind of visualize those automations. Yeah, so that's it's working on that. So what these automations allow us to do now is that every week, say on a Sunday, it'll go through all those papers. On Monday morning, basically present a report, and you can even create this as a PDF or however it is that you consume. So even like EPUB, I use the e-reader, so you can actually present all those results as EPUB. So that's the automation. So it's going to be running. While it's running, let me go back and present the rest of the skills, and then if someone has any questions or anything, we can kind of do that. So let me stop this, and then we were at skills. So we're just going into skills. So skills are something that are becoming probably the most valuable entity of any kind of LLM or AI. And the reason for that is we're now entering into an era where the model itself is becoming so good that they're all pretty much really well done. But a lot of work has shown that fine-tuning models has not been as effective as people thought it would be. Instead, what they've learned is that models have become so good, the general models have become so good that if they're given guidance as to how something is done, they can really do a lot of things in a much more powerful way. What that's called is a harness. So if you have heard of OpenClaw, Hermes agent, so these are harnesses that are built with different tooling that has skills attached to them, and that then allows it to be quite capable, and it can do a lot of things on its own. It also knows how to do different tasks without ever having learned them before. So what a skill is essentially a instruction page that just shows the LLM as if this is going on, this is what you would want to do. These are the tools that you can use, and this is how you can use those tools, and this is the result that you want to show it as. So what that allows it to do is gives it a blueprint, and it makes it both reproducible, and it also makes it extremely reliable. And when we add tooling in there, so think of tooling like anything from having access to a Google email account or any kind of email account, all the way to what we had just discussed with the PubMed access, with clinicaltrials.gov access. When you combine all those three things together with tooling, skills, and the model, the LLM, it becomes a harness. So essentially that's basically what a skill is, and the what we want to kind of make is research focused skills. And the reason it's so valuable in research is that because you have all these different tools that are accessible, we can build skills around them and automate a lot of those things. So the one I wanted to show was these two, of course, so the QI narrative builder and the protocol drafter. And we'll try to demonstrate that in Claude as well to kind of hopefully see how powerful they can be. So like I mentioned, the skill is reusable. It also provides context for what's going on. So this can actually make it an instant. So it can actually be used in many ways. One way that, and this is very much like this thing, me thinking outside the box, where they actually you can use it from an institutional perspective downwards as well. So up, top, down, and bottom up. So if there's certain policies for certain, so one of the ways I use it when I'm building out tools is HIPAA, so and compliance. So um, not that it gives you HIPAA compliance, but it creates a system where the LLM knows that these things are HIPAA compliant and these things are not HIPAA compliant. So now it creates a framework where when it's building apps, it already has those guardrails built in where it's not going to verge into areas where it shouldn't be going into where HIPAA is not applicable. So that's basically what and I would love kind of insights of everybody here just from a discussion perspective on this, but so basically here was like a research decision for Dash was like if there's an environment that kind of has like ethics awareness that that are built specifically for Dash, but also the BC focused health data. So if there's certain tooling that's available for that BC focused health data, it can go and access that, and so it doesn't. So every time that this is built, someone doesn't have to say, okay, access this or use this or do all those things. It's already ready and set up. So Stanford actually did a vibe coding hackathon last week where everybody who basically registered is got a skill, and that skill already had all the access for all the different things, and then they were able to just build out tools using that access. So yeah, so it's an interesting kind of concept, I think, from a top-down perspective that hasn't really been focused on as much, but I think it's something that is starting to happen. And this is the other thing with a skill is you can run skills on a schedule, and this is what makes them automated. So a skill can be scheduled anytime, and so like we had done for the weekly one, you can also do it daily. I have, and then within the skill, as I mentioned, you can also have it email and kind of send out different messages. So yeah, so yeah, so this is a little bit where we're getting into more agentic kind of automations. So essentially, this is what we had spoken about. Is like if a new paper is published, or that trial that had gotten published, we can actually set a trigger where that status of the trial changes, and once that status changes, it will automatically summarize what that paper is published, give us a synthesis, and then we'll get a notification in an email or text as to this is done and now it's completed. This is very useful for labs. Also for lab results or clinical, like any kind of clinical areas where labs are the temporal nature of labs is important. It comes in very handy. And then yeah, so same thing with like calendar reminders, and then any changes that can possibly happen, especially with trials. So now the one thing to understand with skills is that we are kind of when we're building skills, we're and mention this with the dash skill a little bit, is that we want to make sure that methodology is kind of solidified, and that's what skills allow us to do compared to if someone had, and the biggest question usually from this that comes is like, why can't we just prompt it into the LLM? The issue with prompting it into the LLM is that the LLM doesn't always abide by the prompt. It treats the prompt more as a guidance, not as a rule. And a skill allows it to become that rule. Because if one provides a skill, then that it follows that skill to the T compared to a prompt, where sometimes it'll, especially if the prompt is very long, it'll kind of miss the middle part of the prompt, and sometimes if it has contradictory statements, then it will just choose one on its own with no kind of decision making nature around it. Versus a skill, because it'll go through each line by line, it'll have those guidelines in there and follow them very strictly. So with ethics, that's very important, and this is why one of the reasons I had included the protocol drafter, like especially for any kind of grants or any kind of research, IRB ethics, the ethical nature of them, but also kind of like the there has to be a lot of structure around it that is necessary, which is extremely important in building good trials. That is where skills can be very useful. So you make a skill about a certain structure that's needed, and the skills will deploy themselves when the time comes. Same thing with QI. So QI, like having, and I built a couple of these skills, so I'll show them in a second. So yeah, and then so this is kind of how the so this is the end, actually. This is the last slide, but I wanted to show, let's show our Replit project, and then we'll go back to showing the skills. So still building. In the meantime, any questions? I'm just curious.
Yeah, there were a few, and maybe one for me too, just so I can
Sure.
confirm. We can use the vibe coding to build these AI skills that can do anything, like anything that you're thinking can help support my, like, let's say my job, like that's repetitive, or like a task that I could help run in the background. And then I would, as a human, review the outputs, right? Okay, so good.
Exactly. You would review the outputs, and the thing is, like, anytime, so when you run the skill, if say the outputs are bad, you would actually just edit. You're like, okay, I don't like this. Can we, for this skill, can we update this and kind of change that?
Mhm.
And then
Yeah, one of the first questions was just like, because we went from the example you did last session, the PubMed Lit Screener, they just were thinking about like what other purposes can we, which you've kind of touched upon now with the other examples. But one question is about, are you connecting to Claude's API to run the lit review on Replit?
Yes and no. So essentially, what's happening? Yeah, yes. So we are. So the way is, if you think about it, what's happening is there's a few ways that this can be done, and that was going to be our topic next week, was for CDS. So we are connecting to Claude's APIs. Claude is basically, Claude is going in and connecting to, using our platform, connecting to the PubMed API. The PubMed API is giving us all these papers, and it's just coming in as a flow of information. So it's not organized or anything like that. And Claude is then reading all those and organizing it and returning it. So it's done on our side, where we are using the Claude API to organize it together. Any others?
Oh, sure. So if we were to run these workflows every night using the API, I guess maybe for the PubMed Lit Review one, how much would that cost?
Yeah, so that's a very important question. It varies on the model you use, and how much is run. So for Claude, usually, so Claude API costs about $15 per million tokens. So we've probably run, I would say, about like 100,000 tokens so far. And this is where the news around the Chinese models, or the open model from OpenAI with the GPT OSS, those are very important, because if, say for this, if we wanted to run this every night, our cost would be almost like $3 a day or $4 a day. But with something like DeepSeek, which is a model that has the same amount of parameters, basically what that means is, Claude can read 1 million tokens in its context window, which makes it very capable. So Claude, OpenAI GPT, and now DeepSeek actually just got this, was now it can also read 1 million parameters. And what that means is it can read research papers really well. And so DeepSeek costs 40 cents per million tokens. compared to Claude's $15. So you can run this every night, and you can run this 5 times a day, and it will still only come out to like maybe 10 cents, 15 cents. Um, so that's where the model choice comes and becomes a bigger factor. The reason I ran Claude here, the Sonnet especially, was just because it's a little bit faster as an integration. DeepSeek is fast as well, but it's not as fast as Sonnet is. So and that's the main reason why. So that is something to consider, especially if it's being used for personal use. I tend to prefer like DeepSeek or Quen, are very capable and very useful for that. And it's still building. While since it's and this is why I'd done this earlier because I knew this was going to happen. It's a pretty significant build. So usually just to give you an idea, so like time wise, so this takes about the initial build always takes about 20 minutes, especially if it's like a very good comprehensive build. Then it takes about 25 minutes, and then anything added on probably takes about another 10 minutes to add on onto the models. So I want to go over skills if possible, or and then we can come back to this if it's built out. So what is this skill essentially? So a skill is, let me share. So I'm going to share my Obsidian folder. So Obsidian is essentially where I store everything. So this is one of my notes from here. Can you guys see this? Okay, good. So yeah, so this is the dash research skill I have made. So basically, a skill is broken down into a few things. So up top, every skill, no matter where you make it. So and before I should prerequisite this by saying that there about 2 months ago, all the different AI companies, all the different AI labs, they basically got together and they decided on a standard structure for skills. So now you don't have to worry about if you make a skill in Claude, you don't have to worry about, is Gemini going to be able to use it, or is Codex going to be able to use it? Everybody now uses this standardized skill format that can be copied and pasted anywhere. So the way these work is that they usually are files, so they're markdown files, which you can download online and get from there, and then drop it into Codex, Claude, Replit, Gemini, anywhere, and they can use. So skill usually has, this is called a YAML or YAML, and this is the header usually, and this is where this has the name, this is what the description is. Why this is important is because this is how if something is done, like say tomorrow we search, I'm working on a project for Dash for research, it'll know that this is a skill it can possibly go in and use for that, and it can automatically kind of bring up. Versus if this was not there, then it would not know to do that. And it would be like, because anytime Claude runs, it goes through the skills that it has available and sees, oh, do I have something available that'll help me with this? And then it'll run that. So, and then in there, it'll have all this information. So you are a research flow assistant. This is what you, workflow assistant, this is what you do. And then this is your operating principle. So so again, so this is those are the rules. So like AI drafts, the researcher is always the one who decides, and then you produce these drafts, and this is the context of the cluster where this is going back to those things. So like say if you were to open a Claude window today and not have any skills attached, this is something that whoever is doing it, they would have to mention that this BC health data infrastructure exists. This is what it has. Versus the skill, if it's like, oh, just use this skill, it'll know that this is all those things available automatically, and no one has to kind of mention that. So this is very useful for I think for teaching a lot of people. So like a lot of other clinicians, if they want to build tools, I usually just send them my HIPAA skill, because then they know that these are things they can do, these are things they can't do, and then when it comes time for like a compliance test, it'll be much faster. And this is the ethics framework that we use, and then when to invoke the skills. This is that part, and then it's like activated skill. When you have a UBC Dash researcher, or if anybody asks about data, or if there's any mention of a digital health, digital support, or if there's mention of TCP. So it knows to use it at that time. And then this is the workflow that it would, and this is again going back to the prompt versus skill. A skill gives it this workflow that it should be using, versus a prompt would just give it a kind of a methodology that it has to maybe or maybe not ascribe by. And so this is these are the tasks, and then and this is very very detailed. I so what I did was I went through the whole Dash kind of like how a lot of the documents in Dash and all those things, and I tried to get every. Hopefully this is useful. I don't know, but so just wanted to give an idea. Kind of these are the different steps that it goes through, and then for all the linked data, this is how you do the planning, create these maps, create these data sets, and then for any kind of decision support, you have to use evidence and have like FHIR in there and all these the ethics involved, and then the output format, of course. So remember, output always has to be very standardized. So it's this first task summary, then the context applied, and then the primary output considerations, and then next steps. And these are all the guardrails. Yep. So that's kind of the skill for this. And then again, going back to context, examples are gold. So if you can provide even one example, but even more than that, like two or three examples, then it really knows as to how to go about and how to use the skill and how to kind of give the result. So that's this one. And then I made one and I'm going to post these onto either whatever is preferable, either GitHub or a different where you can review these. But again, the easiest way to make these is just have prompt Claude to make them. And basically, for the best way to do it is actually have a whole conversation with Claude, and then on like this is what I'm thinking about. This is what we want to do, and then at the end of that conversation, can you convert what we spoke about, what we discussed into a skill? That is the best kind of skill that comes about. Cool. And so it is, that's that. And then let me see, where we're at with my still, still going. Any other questions in the meantime?
I think people appreciated last time how you kind of gave them some steps on like how to walk through creating that PubMed screener, or if there's some type of guide, or I guess we'll share your presentation slides after. But if
Yeah.
there's any other step-by-step guidance we could include in that, we can follow
Yeah,
up.
exactly. Yeah, we have a course on Dr. Vibe on how to build a skill, but also
Okay.
I can send there's or I've made a guide, so I'll send over that guide
Great.
to do that. And for longer skills, how does it impact the context window? So that's a good question as well. So actually, it's the skills are the best place for um like I'm trying to understand the question. Is it like how does it impact context window from the LLM perspective? So if it's from the LLM perspective, skills are actually the best way to manage context window. So one of the issues with like OpenClaw and Hermes agent right now is that context is a mess. So like memory especially. So memory in general in LLMs as a whole is something that hasn't been solved well yet. And one of the ways that one of the problems is that context gets so large that the LLM has to go through billions of tokens to understand just answer like how's your day going. And so one way that context can be managed is it become when you make something a skill, it doesn't always have to go back to memory. Like how did I do that? And same thing with like how we do it. How did I do that? If we have a guideline of how we do that, then it becomes more efficient. So it does help manage context window a lot better. And if it's flipped, like if the question is more like if it's a longer skill and it's a large context, they still tend to be more efficient with the longer skill compared to if it was a longer prompt. So this is still the better option. What a more comprehensive way of doing it is, and a little bit outside of the scope, is making scripts within skills, so that you actually can do skills within skills. And so then you're like, okay, if in that skill we had like the BC kind of data infrastructure, you could have a separate skill for just BC data infrastructure and have it reference that and be like, okay, access this skill. And then now you have a skill within a skill within a skill. So then that kind of becomes a little more comprehensive. But and then the next question is how do we make a physical project implementing one of the workflow that you recommend, like a Git repo? Um, uh, how do you actually make it? Is that like is it like how do you so Git repos are very easy to make if that's the question. You could make it on GitHub, and again the main what a Git repo allows you to do is essentially um kind of organize everything in one place. So the way Claude works, and if anyone's used Claude Code and Claude Cowork, is that they work in a folder. So that folder is what's called a repo. Just think of that same folder as like a folder in the cloud, but it's in GitHub. And GitHub essentially manages versions. And the reason that versions are important is that if you're making changes to code, if something breaks, you can always go back to an older version and kind of manage that way. And then it also the other place that it's useful is that if multiple people are working on a project, if you have a team, then everybody can put it into one place, and GitHub manages just like merging that code and merging the project together. So that's the best place to do that if we're doing that. Um, cool. Any other thing or automations? Oh, here. Our automations are done. If you guys want to see them really quick, and then I'll go back to the questions. Um, So, just really quickly, and I promise I'll go back to questions. So, these are the automations. So this is ad hoc. So this is running as we need it. For automations, like create our first automation. So then this is our weekly kind of so just a weekly GLP cardiovascular review, and this is going to be focused, in this area or not. And then this is the question. And then once we do the automation, so this is weekly, it'll run weekly, and then kind of just my password manager doesn't like. So and yeah, so now it's going to be running every Monday at 1 p.m. UTC, and then every Monday you'll get a whole list of these are all the papers that were done. So the next iteration of this would be agentic. So say like we run the automation, and the automation comes out with a new paper, and it's like okay, this is flagged. Now an agent can pick that up and be like, okay, why was this the case? And then we can add if this happened, how does this impact XYZ? Like if we're working on something else, and this becomes a little bit complicated. So like if this is connected to say a clinical trial, then you can actually automate that and see how those changes have impacted some results from that trial. So and same thing with like email. If you wanted to add like email, there's an agent that can kind of summarize it as an email, send it out, and all those things. So essentially, this is where like automations can be extremely powerful to where they almost blur the lines to where what's automated and what's agentic. A lot of things, to be frankly honest, on the market are more automations than they are agents. And it's almost like use of AI built on the ground, but it's all automations running on a cron versus actual agentic use. So I'll stop sharing, and then we can do the questions the rest of the time. So the question is, can we make it reproducible like we use seed so it results in the same result? Can we design something like that? Yes, exactly. So that is the best use case for skills, is making it reproducible to where and reliable to where if we are using certain protocols, those protocols are always followed. And then it's also, and that's a good point. That's actually an amazing point. So it almost makes sense to sometimes run the same question 5, 6 times. I like to do that with anything I run, just to see what the drift is on the results. Because if the drift is too much, then there's not a lot of structure, and and then it may need a little bit more guardrails. Maybe it needs a little more guidelines. And if there's no drift, then it's good. Then that's something that's reliable. And then the other question is, how would you differentiate between choosing to deploy these kind of tools through Vercel, Lovable, or any other tool? It really varies. Vercel is amazing. One of the benefits of Vercel is that actually Claude you can deploy directly from Claude using Vercel and Railway, and so that's one of the benefits of Vercel. Compared to Lovable, Lovable is more like Replit. So Replit is more its own thing, an IDE which has its own platform. We discussed a little bit last time, was from a certain from beginner perspective, I tend to prefer either Replit or Lovable. I say Lovable with an asterisk because they literally just had a hack a week ago. So they had a lot of, and what happened was they had a lot of exposed APIs. So a lot of people who had put their, like, say, Claude API in there, you could just go into, you could press F12 on the browser and just copy the API key and then plug it into for your app and start using it. So that was the dangerous thing with it. So with Replit, what it does is that it actually screens and has a security agent that screens to make sure you're not doing anything like that. And also the code is secure. With Claude, actually, Claude has a security skill. So anytime you're ready to deploy, just have it do like just say, Claude, can you do a security audit? And it'll actually tell you if your APIs are exposed or if there's anything else going on that's a security risk. And same with Codex and Lovable now as well. Cool.
Thank you, Omar. I was just looking at the time that I can't believe an hour has gone by so fast.
Yeah.
And there's so much content that we could probably keep talking for another hour. We do want to let everyone know that we do have a third session on May 13th, which is the building clinical and operational tools and where to go next. Maybe Omar, do you want to just give a little summary of what that will be? And do you want people to give you ideas for like what examples to use for that session or?
Yes, that would be great. I think that would be I want to make that one as hands-on as possible. I don't really have as much to, like, with this. I think the best part about vibe coding is that anyone can learn pretty quickly. So these are the main foundational tools. So we'll primarily go into, like, how is it from a clinical perspective? What is it that you use? What you have, like problems you have, and best place to find vibe coding solutions is solving your own problems. So if you have any problems, let us know and we'll focus on those and solving those. And then we'll kind of go a little bit into clinical decision support tools. That's becoming a big thing now. And kind of integrating more clinical tools into practice. So PubMed is a good example of research tool, but now there's clinical tools as well, like calculators that we can build and also simulations. A little bit on digital twins. It's still a very early area because I think there's a lot of development still left to be done over there, but we'll touch base on that as well.
Great. Thank you so much for today's presentation, Omar. It was really insightful, and I will get your notes about making my job a little bit easier for that dash workflow. So thank you again. Please, everyone, you can join us again on May 13th for the final session of the Vibe Coding for Healthcare 101 webinar, and everybody have a great rest of the day. Thank you.
Thank you.